Hi there, and welcome back to our 8th episode on SRE and DevOps. My name is Seth, and I'm a developer advocate at Google focused on infrastructure and operations.
And I'm Liz Fong-Jones, a site reliability engineer at Google, where I teach Google Cloud customers how to build and operate reliable services. So last time we were talking about SLO burn alerts, and Seth, you were really skeptical about letting go of your alerts about every single potential root cause in the system.
Yeah, honestly, it's terrifying to let go of all of these alerts that we've painstakingly built in the past that have happened as a result of an outage or would have prevented an outage from happening.
I totally hear that, but what we need are better ways of finding problems in our systems that don't necessarily rely on making assumptions about what's broken before, rather than layering on technical debt after every outage.
So I've heard there was a word for that, observability.
Yeah, that's it.
We need to make our systems observable rather than only being able to debug what we've thought to log or monitor or alert on in the past.
Exactly. So observability breaks down into 3 key areas: structured logs, metrics, and traces. Structured logs are emitted by each process and may contain a mixture of information ranging from records of individual user queries to debugging information generically associated with our service. Metrics reflect aggregate typed data about the performance of services, such as the number of queries, which is a counter, their latencies, which is a distribution, and the CPU load, which might be a gauge. And traces allow for individual execution flows to be traced through the system, including timing and dependency details.
So I see, and all of this makes sense, but I still don't understand. How does this help me better understand and diagnose my problems?
Let's take an example. So we use metrics as part of our service level indicators, right, in order to monitor outages that are spending our error budget faster than we can tolerate. So once we have an indication that something's wrong, we need to figure out where in the system is broken. And can we mitigate it by draining a zone or specific set of replicas? And we might need to drill down into the metrics in order to find out what are the commonalities between the slow and erroring queries. For instance, do they have a shared zone or a shared set of dependencies? Or maybe a different version of the code that is new that we just rolled out? So we might use traces after that to find the interaction between the components that's causing these slow or failing queries. And we might need to use the logs to understand each failure in detail.
So if I'm understanding correctly, once I get paged, I might look at these kind of dashboards of all these different metrics with common starting points for queries, such as breakdown by region, etc. And even though I'm only getting paged on these kind of higher level issues, I'll still collect information about these lower level issues, which could help me debug the root cause.
Exactly. And then you'd need to edit your queries to further drill down or get breakdowns intersected with other properties, for instance, the build version or the set of feature flags. You don't necessarily need to alert on every metric you collect, just on the error budget, but having that information available really helps you do need to diagnose problems.
OK, so I'm with you so far, but then where does tracing come in?
If you see that queries are slow at the top level, it's often helpful to be able to skip down directly to where you think the problem might be happening layers deep in the system. So the best and easiest way of doing that is having a visual representation of where is the time spent in your queries? Where's the new bottleneck that's increasing your latency?
OK, so I've pulled up on the traces dashboard, and I can see that most of my queries are completing in about 50 milliseconds in Cloud Bigtable, but there are a few queries that are orders of magnitude larger, taking longer to complete. I also noticed that many of the slow queries happen to be on the same row in Cloud Bigtable.
That sounds an awful lot like a hotspot, Seth.
Definitely, it smells that way too. I see now, and I can look at the relevant logs on individual replicas that the tracing is suggesting to help understand why that same row is being queried repeatedly and why that query is so slow. So I can see how this architecture helps me identify and solve problems faster, but what if I'm not already using these types of observability tools? What if I'm coming from a traditional monitor solution, or it's kind of embarrassing to admit, but I still grep through log files manually? How do I get started with something like this?
Don't be so scared, Seth. That's a great question. I'm glad that you asked. Google Cloud offers a suite of tools called Stackdriver, including Stackdriver Monitoring, Stackdriver APM Trace, and Stackdriver Logs, that let you adopt all of these techniques, and there are really cool integrations between all of these various observability methodologies. But you should start by measuring your SLOs first in Stackdriver Monitoring and Stackdriver SLO.
Great. I'm glad to have learned so much today and hope all of you did as well. Thank you for watching, and we hope to catch you next time, where we'll discuss how to resolve incidents with as little chaos as possible. To find out when we post our upcoming episodes, please like and subscribe below.